Today's episode is called The Violation That Scores 0, Object-Centric Conformance Checking and the Identity Blind Spot. So, let's look at this case. So we have a worker, worker 1, worker 2, and we have a supervisor. The supervisor assigned task A to worker 1 and task B to worker 2. Now, at runtime, what will happen is that they got swapped. So worker 1 did task B and worker 2 did task A. The issue now is that, so this is a violation. The assignment was violated. The assignment of the supervisor was violated. The problem is that if you run conformance checking against the model, worker 1 processed the task, worker 2 processed the task, both tasks were processed, and we have fitness 100% and cost is 0. It's telling us that it's a perfect fit. The issue is that actually we have an invisible violation. A real interaction violation just scored the perfect fit, and the tool is working as defined. So this is a problem. The next slide, we're gonna see why is that. So let's look at this problem. We have our task place. The issue that we have is that we do not know if this token, which is which. So is this token task A or is it task B? Or is this token task A or task B? So we know the type of the tokens that are here, of the objects, but we do not know the identity. Let's look at it more precisely when we are trying to do a conformance replay. So we are doing our conformance replay and we are checking per token flow. Here we are trying to fire process. We just care, hey, do I have a worker? Do I have a task? I'm gonna consume these 2 tokens. I'm gonna produce a done task. That's all I care about. I do not care which is which. So if there is a swapping between which process is being done, or let's say process of ID 1 is usually done by different workers at different tasks, but it is done by worker B, for example, instead of worker A. It will not be detected. We only care about the process being fired, which is a problem. So, because if we go through the identical markings at every step and the alignment cost is 0, it will not be detected. This brings us to our conclusion that if types are conforming, and even if the identities cross, standard object-centric conformance will be identity blind, which is a problem for us. So to catch the swap, you need 2 things. You need, which are of course missing from the object-centric nets. First of all, you need identity, an ID, an identifier, and transitions that compare the identities. So this results in what we call an O, and here task is not just, so it's not just a token, it's task A. We know which task it is, and the process transition can carry a guard. Here we have a guard, and it says fire only if the worker equals the worker this task was assigned to. So it will only fire here if these 2 match in the E2O table. The swap now is failing. Only the correct process is working, and it also brings an idea that is very important: synchronization. So an object, we have subset synchronization, means an object flows through an activity only if some related objects flow too. So it needs to be the correct objects, and exact synchronization only if, meaning that only if all related objects flow too. So the textbook example of all of this is that bill in order only when some or all of its packages have been delivered. So this is the, so if you take the false order and you assign it the false packages, and then that would create problems, of course. So this was standardized in a 2025 paper from Gianola, Montaglia, and Winkler. This is an interesting paper, so check it out. So if you're watching this and you know of OCEL, you might tell me, yeah, but we can check this with your O2O and your E2O table, and you'd be correct. So if here we have task A that is assigned to worker 1, and then the process of task A is done by work 2 in your E2O table, so you have contradiction here, and you don't need alignment, you don't need all what we have been talking about. So the precise claim is that the swap is invisible to the standard object-centric Petri net stack. The token, replay, fitness level type are not detectable in principle. So it's not that nothing can catch it. So that's the caveat here. And one thing I wanted to say is that there is no mainstream tool. So it's the caveat on the caveat here. There is no mainstream tool that ships qualified consistency check. So we have already spoken in episode 14 about OC declare here. And here they were talking about co-occurrence. Co-occurrence is not an ID check. Co-occurrence is not an ID check. It's a type check. It's just saying, yeah, an order with all its items. We are not knowing which is which. Like, we are not following which is which. So the true identity binding is processed by the assigned worker, like processed by correct person, is in OPID, DOPID territory. So check this out. It's an interesting idea in research. So here, let's look at what's shipping today. So we do not need to look for functions that are not there. So PM4Pi gives you an object-centric discovery plus per type token replay, like produced, consumed, missing, remaining. So it's not full conformance. Conformance, so the following function is manual only and confirmed. So you do not rely on it yet. So it's not in the verified public API yet. So real object-centric fitness and precision live in a separate library. So it's OCPA. But it is OCL 1.0 only. It's not OCL 2.0. There is a video, one of my videos, where I'm discussing the difference between OCL 1.0 and 2.0. And it times out on large logs. So that's another issue that OCPA has. Identity and synchronization aware alignments. So for example, these papers, these are research libraries, research prototypes, and they are not really production libraries. So for now, like, let me get back here. So the gap and the issue that we have today is that the papers are ahead of the tooling. So what's happening is that discovery is scaling, identity aware conformance is not. So we need identity aware conformance, and that's the next step that would be interesting to have in production. So to finalize, as always, 32.3% of failures of multi-agent systems come from the interactions between the agents. This is the paper, one of the most observational papers that we have out there. So, and also no one has published object-centric conformance on multi-agent LLM traces. So there is actually a paper that is close to that. I believe that was released early this year in 2026, but I will need to read it more deeply to inform you about it. But for now, as of release of the date, I haven't read any paper like that. I believe there is a paper of 2026. I will update this video if it is the case. So type level conformance would score many broken runs as perfect fit. So that's another thing. And here we are discussing this issue. 3 things to keep in mind. These are the elements that we discussed today. I will not have to go through them one by one, but you can, if one of these elements you don't know, you can review them on your own. And finally, there is one more frontier before we go. It's online conformance. That will be the next video. So it's checking a run as it streams with prefix alignments. Is single case only today. So this is a single case only today. object-centric on live stream is double frontier. So that's where we are headed. This is where I will be talking in the next video about live online conformance. So if you like the content, please like and subscribe, and follow me on LinkedIn as usual.